Let me explain you one more thing here. I take some space here now. If suppose we know N2 into 5 to 1 is equal to M into I1. We know like this because we know M is equal to what is mutual inductance? N2 5 to 1 by I1 like this. So we can say by Faraday's law E is equal to minus d phi 2 by dt. That means we can say, see here, we can say like this also, what? M into di1 by d2 like this. It is also a mutual inductance formula. Got it? 5 to 1 and N2 will be outside. Okay, got it? Now this is also, we have studied similar example for self-inductance. Okay, same formula. In place of L I have written here M. Remember that L was self-inductance and here M is coefficient of mutual inductance. Okay, now one example, I take one more example. Suppose we are having two coils like this, having different radius. Suppose it is having radius R1 and N1 turns, and another coil of radius R2 and N2 turns. Okay, we know that we can say that R2 is very much greater than R1. We can say M is equal to M1, M12 is equal to N1 512 by I2. That we know by formula. We can say that N1 by into 512, the flux linking with first coil by second coil. We can say like this, B1 B2 into A1. For 512, we can write B2 into A1. Okay, by I2. I can write like this also, N1 into B2 means magnetic field at the center of this second coil. We know for circular coil at the center, what is the magnetic field? We know that mu naught I2 for N turns N2 by 2R. That we know. Into area we can say pi of A1 means R1 square by I2. Solve it and you will get the answer for this coil. Okay, got it? Okay, this is the formula for, this is the concept for two coils having turns of N1 and N2. Okay, and simply if someone asks that we are having single coil like this, one coil and second coil, so that is N2 is 1 and N1 is 1. What you will do? Just put N2 is equal to 1 and N1 is equal to 1. You will get the value of mutual inductance. Okay, this question have been asked in your exam. Just put N2 is equal to 1 here and N1 is equal to 1 here. You will get mutual inductance for these two coil having single turns. Okay, this was the topic that we were trying to study. Okay, now let us start a new topic, that is energy stored in inductor. I will start this topic with the concept, you know, 1 minute. Yes, we know one more concept earlier also, Kirchhoff's law. You know that for a Kirchhoff's law, let us, I start my discussion with Kirchhoff's law. Okay, now you know, if suppose the inductor is having E and suppose current is flowing like this. Now if you are moving in this direction, remember, okay, remember the Kirchhoff's law we have studied. If we are moving in this direction, direction of current, we will say voltage drop is equal to what? Minus L di by dt. If we are moving in opposite direction of current, what will be the voltage? It will be V of L di by dt, like this. Okay, now we know this is the formula, this is the concept for applying Kirchhoff's law for inductor. Okay, Now we can say like this, since we know that, we also know that E is equal to, we know by Kirchhoff's, by Faraday's law like this, from where we have written this, you know, E is equal to minus d phi by dt. We have studied in our previous class, and it is equal to minus L di by dt. From there only, since it was EMF, so I have written here voltage. Okay, now let me take one example and show you what is the energy stored in self inductance or an inductor having inductance L. Suppose we are having one inductor and one resistor circuit containing one inductor and one resistor, and they are connected to a source or having EMF E. If suppose current I is flowing through this loop, we can write by Kirchhoff's law what? E minus, here we are increasing the voltage, we will say E minus, we can say minus, in direction of current, moving direction of current, we can say minus L di by dt minus I into R is equal to 0. Okay, what we do? We multiply here by I dt. What we will get? We are multiplying here. What we will get? We will get here, see here, what we will get? E minus E into I dt minus, what was it? See here, what was it? It was L di by dt into I dt minus IR into I dt is equal to 0. See here what it comes? It comes E into I into dt minus dt cancel here. I can write like this, L I di minus I square R dt equal to 0. If you integrate here, see, if you are integrating here, what you will get? For variable time 0 to t, for current 0 to I, and for time 0 to t, what you will get? You can see here, I can rearrange it and I can write like this, integration of I dt is equal to, I am sending these two terms right side, I will get L outside, L dt I di plus I square R integration of dt 0 to t, 0 to I, and 0 to t. See here, see, remember one important concept we are saying here. See, voltage into current, that is power, and power into time is energy. This is the energy supplied. This is the total energy supplied by battery. Okay, and this is the energy stored in inductor. This is energy stored in inductor. If suppose anyone asks what is the energy stored in inductor, how will you find? You will use this formula. Okay, this is the heat produced or energy wasted. Heat produced. Okay, now from here we can say that energy stored in inductor, will be how much? It will be equal to integration of I di, that means 0 to I. If you solve it, what you will get? Half L I square. And you remember this very important formula, energy stored in inductor is half L I square. Okay, now if we try to find energy density, we say it as small u. What it will be? It will be energy stored by volume. What is the volume? Volume means this volume, energy of mid space, this volume. What is the volume? This volume. Okay, this volume, mid space, volume of mid space, So we can write here what will be the energy density. We can write here U is equal to energy density. You can write here half Li square, half Li square by volume. What will the volume? Let us suppose it is area is cross section is A and length is L. Okay, now we can write like this for self inductance of a solenoid. We know it is how much? Half. I write here self inductance of solenoid. I can write like this. What? Mu naught. You remember self inductance of solenoid? What it is? It is L is equal to mu naught n square L A to L. You remember this self inductance of solenoid? This was self inductance of solenoid. Put here mu naught n square A into L into I square. Okay, put and solve this. You will get U is equal to how much? You will get how much? You will get mu naught n I whole square by 2 mu naught. That means what it is? It is b square by 2 mu naught. This is the formula of energy density. Okay, this is important formula and this is important formula.